Hello, welcome back. In this segment, I wanted to show you how you can test whether a machine is Little-Endian or Big-Endian when it is storing the data, in memory. So what this program is doing is it's supposed to return us 1 if the machine is Little-Endian, otherwise it returns 0. Let's walk through this program. We have a sample variable x is equal to 1. You could pick any other value, but I chose x equal to 1 because it will be clear why in a moment. We choose x to be 1 here to make it easy for this analysis. We take the address of x. Address of x means a particular byte's address, okay? If you treat integer as a 4-byte number, you have in hex, it will be like hex representation of this number 1, right? And the question is, when you do ampersand x, we don't really know exactly where it is pointing to. It could be pointing here to this byte or this byte. Okay, doesn't matter. We are going to test that. If it was pointing over here, right? Let's assume it is pointing over here. What will happen in that case? Ampersand x is pointing over to this byte. That means ampersand x means just an address, okay? And why are we casting it to char pointer? Because ampersand x is an integer type. Okay, here is the int type. Ampersand x means int star type. This is int star type. Okay, we have to cast that into a char pointer because our goal is to read 1 byte at a time. Char allows us to do 1 byte at a time. That's the reason why we are casting it to char pointer. Okay, once we cast it to char pointer, now we are basically pointing to only 1 byte. And we are asking the value at that byte by putting a star at the beginning, okay? So if we were pointing here, we will be having the value byte to be 0, 1. On the other hand, if we are pointing here, the byte will be assigned to value 0. Okay, so that's basically it. And let me just draw some artificial address to show you the concept. Suppose we have 4 bytes like this, okay? And I'm going to choose some artificial address. Say this is address 20, and this is address 21. If the machine is Little-Endian, where will the ampersand x point to? It will clearly point to the lowest address, okay, which is having the value 0, 1. So we will be returning 1 if the machine is Little-Endian, okay? If, on the other hand, if the machine is configured as a Big-Endian machine, so what will happen in that case is that we can take the number as follows. We will write it as 0, 0. This is basically the representation for Big-Endian. This is Big-Endian, BE, and this is Little-Endian, LE. Okay, that's all. And the program will return 0 in our Big-Endian case if the machine is actually a Big-Endian machine. It will point to this value. Okay, I hope it's clear. We are basically taking the address and looking at the value of that address. And if the lowest address value is 0, 1, then we know we are pointing to the least significant byte in the case of Little-Endian. If the lowest address has the value 0, 0, we know it is pointing to the most significant byte. That means it must be a Big-Endian. Okay. We are choosing 1 because we know how to easily convert 1 into binary representation, equivalently x. That's the reason we are choosing. Let us quickly rewrite this program so that it's easy to follow. In case you are not familiar with pointer magics, it will be easier if I rewrite it as follows. Char pointer ptr as first take the address of x and cast it to a char pointer. And now we can read the individual byte value by doing star ptr. That will give us only 1 byte, okay, because character is a byte. That's the representation we assume. Okay, and now we can compile this code and look at the output. Little-Endian value is to be 1. Yeah, you see here it's returning 1 because this machine is a Little-Endian machine. Okay, very quickly I want to summarize what we learned. We have a sample here, x is equal to 1. We compute the address of x. We don't know whether the value is pointing to the 0, 0 at the beginning or 0, 1 at the end. At this point, we don't care so much. We get an address, and that content of the address is read in the next line. Whenever you put a star followed by a pointer, you're basically reading the value at that address. And then we are returning the byte. If the byte is 1, we know that the star PTR is 1, which means PTR is pointing to the least significant byte, because only the least significant byte has the value 1. Okay, so that means the machine is storing the least significant byte at the lowest address. That's basically the point. All right, that's all. Thank you very much.